All right, so we're going to go ahead and get started. Now we're going to look at mixture problems first. And for these questions, we're going to draw a diagram, draw a picture. And we're going to use that picture to make our equation. The textbook uses tables, and I used to teach with tables, but I found that students get more confused with the table than a picture. So I'm actually on page 178. And we're going to look now at question 21. So 178 if you want to follow along. Now when we mix different chemicals together, what we've got is we've got an amount, like how many liters or how many gallons. And then the concentration, how strong that chemical composition is. So you're going to have an amount, and you're also going to have a percentage rate. And we're going to have two of them combined together to make the third. So we're going to look at question 21. And we're really going to take our time and learn how to set these up, because they're very, very important for intermediate and also college algebra. We just go through the same questions, just a lot faster in each one. So question 21. In a chemistry class, 12 liters of a 12% alcohol solution must be mixed with 20% solution to obtain a 14% solution. How many liters of the 20% solution are needed? So each of these is going to have an amount and a percentage rate that goes along with it. We're going to draw boxes to represent these containers. And we're going to need three of them. 1 plus 2 makes it 3. So we're going to draw our containers. And this, by the way, is on page 178. And we're going to be looking at question 21. And so we've got these three containers. And the way that I remember the containers is 1 plus 2 equals 3. So they're going to add across. And each of these is going to have an amount and a percentage rate that goes along with it. So we've got our box set up. We're now going to have to fill this in. So we start by reading it again. In a chemistry class, 12 liters of a 12% solution. So my first box is 12 liters, so that 12 goes there. Percentage rate is also 12%. So that's my first container. 12 liters, 12%. So that's the first piece. We've got to get all three. And we're going to mix that with a 20% solution. So we're going to mix that with a 20% solution. And it does not tell us how many liters of that 20% we have. So that's going to be our unknown. So that's going to be our x, because that's what we need to find. These add across. So 1 plus 2 is 3, and these are going to add across as well. Now the 12 and the x can't go together, so that's simply going to be 12 plus x. And we're going to mix them together, and this is what we want at the end. So this is our result. This is what we get at the end. At the end. So at the end, when we mix these together, we want to obtain a 14% solution. So when we mix them together, that result, that end result now, is going to be 14%. So now we have everything filled out. So we've got a container that has 12 liters of a 12% solution. So that's box 1. We're going to mix that with another container of unknown amount that's 20% for the concentration. They're going to add together across, so that gives you 12 plus x, and our result is a 14% solution. So that is our table, our diagram. So we're now going to use this to make our equation. And how do we do that? Well, we do that by looking at what's called the pure. And the pure is the amount times the percentage rate as a decimal. So pure is always the same, and it's the amount times the rate. So what do we have for our first one? Let's look at our amount and our rate. Well, that's 12%. 12 for the amount. So that's 12 times 0.12, because 12% is 0.12. So that's your first container. Again, doesn't matter the order, because it's all commutative. What about the next one? Okay, the next one is 20%. So that's 0.2. And how much is in there? X. These add together to give you box 3. Box 3 is a 14%, so that's 0.14. How much is in there for the amount? 12 plus x. And as we do more of these, it'll start to make more sense, and it'll become a lot easier. So we just label our picture up here. These two multiply together to give you that. Those two give you that. Those two give you that. Now we can solve it out, and be careful with your decimals. So we're going to go ahead and distribute through and combine. And we've got 12 times 0.12. I believe that's 1.44. Let me double check. When you multiply them here, this gives you 1.44 plus that 0.2x. Distributing through, 0.14 times 12 on the other side. That gives you 1.68. And distributing through, that gives you a 0.14x. So just be careful and take your time with these decimals. And again, I know this is brand new. We're going to look at several of these. All the problems in this section are set up pretty much the same. It's just either investment, mixture, or distance. This is a mixture problem. Go ahead now and solve this out. So take away that 0.14x from each side. That leaves you with 1.44. Adding those together, plus, and watch your decimals here, 0.06x, and that equals the 1.68. So let's just put together. That gave us that. Now we'll move that 1.44 over. We are left with 0.06x, and using our calculator here, we have 1.68 minus 1.44. That is 0.24. Divide by 0.06. And that leaves us with x equaling now, when we divide out, I think, 4. Yep, that's going to come out to be 4. And what's our answer going to be? Well, that goes with the 20%, right? So that goes with this one here. Here's our x. X was 4. So what do we have? For our answer, we have 4 liters of 20%. So that's going to be your answer on that. 4 liters of 20%. I know it's kind of confusing, but the more of these we do, the easier they're going to become. Let's look at Let's look at question, how about 24? Question 24. Water must be added to 150 milliliters of a 10% essential oil solution to dilute it to 5%. How many milliliters of water should be used? And it gives you a hint here. Water is 0% essential oil, so its rate's going to be 0. So let's go ahead and see what we've got. Again, we're going to draw our 3 boxes out. And sometimes it might be easier to label them too. So we're going to start here with what? If we read question 24, it says water must be added to 150 milliliters of a 10% solution. So we're going to start now with 150 milliliters. So that's going here. That's your amount. And percentage rate is 10%. We're then going to mix this with some water. Now, do we know how much water we need? Does it tell us in that question at all? No, because that's what we're trying to find. All right, so we're trying to find how much water we need. So we don't know the amount of water, so we're going to use an X here. And what is the percentage rate of oil in that water? Should water have any oil in it to begin with? No, it's clean, right? Should be clean water. So the percentage of oil in water right now at the very beginning should be 0. It's clean water, so the percentage of oil in that water should be 0%. Now we're going to add them across again. So these add together because 1 plus 2 gives you 3. So that is then 150 plus X when we add it across. And this is what we want to end up with. Okay, we want to end up with this. This is what we want to end up with, our result. And what concentration do we want to end up with? It says we want to dilute it down to give me a 5% solution. So we want to end up with a 5% solution for our result. So we want to end up with the 5%, so that's going here. So this is what we start with, 150 milliliters of a 10% solution. We mix it with some water. We don't know how many milliliters, so we use an X. Water is always pure and it has a concentration of 0. Nothing else should be in that water but water, so it should be a percentage of 0. We're going to mix those together, so these add across because 1 plus 2 is 3. And that gives you that 150 plus X. And reading the question, we want to end up with a 5% solution. So that goes here. Now we can go ahead and come up with our equation using our pure. So pure again is the amount times the percentage rate. So amount times the rate. And what's that going to be for our first one? Well, 10% is a decimal, 0.1. And how much is in there? 150. We're going to add that to the second one. 0% is 0 times X. And what about the third one? 5%. Now be careful with your decimals. It's not 0.5, right? 5% is 0.05. And how much is in there? 150 plus x. Now, what do we know about 0 times x? 0 times x is just simply 0. So that's actually gone, right? So that's gone. 0 times anything is just 0. 150 times that 0.1, that should be 15. So this is going to come down to be 15. And we're going to distribute through here. So 150 times 0.05, I believe that's 7.5. Yep, and it is. So that's 7.5 plus 0.05x. Okay. Now we're going to go ahead and solve this. So we're going to subtract off that 7.5 from each side. And that leaves me then with 7.5 equals 0.05x. We're going to divide by our 0.05. And that then leaves me with x equaling. Let's put our x on the left now. So that gives us x equaling now when we divide out. 7.5 divided by 0.05. That's going to divide out, and that's going to give you 150. So what does that tell us? That tells us the x goes here with the water. So we need 150 milliliters of water. Now for the next ones, just because of time, I am not going to solve them out, but I'm going to set them up. So the next two, I am not going to solve them out. I'm going to get us to the equation, and that's where students always struggle, is getting to the equation. Most of you can solve this equation without a lot of difficulty. Where students really struggle is, how do I set it up? How do I get to that point? So for the next two questions, we're only going to set them up. But that gives us more time to do more examples. So we're going to look now at question 25 and 26. I'm not going to solve them out completely. I'm just going to get you to the equation. And if you want to finish them out, you can. But the hard part is always getting to that equation. Question 25. How many liters of 60% acid solution must be mixed with a 75% acid solution to obtain 20 liters of a 72%? So let's now go ahead and try to create our diagram. 1, 2, and 3. And we've got amounts, and we also have percentage rates for each one. How many liters of a 60% acid solution? So the 60% is going to go there for box 1. We do not know the amount. It doesn't tell us. So we don't know. So the amount is going to be X. We're then going to mix that with a 75% solution. And we'll come back to this box here in a moment. And we're going to mix these together. And this gives us, this is what we want at the end. What we want at the end. When we mix these together at the end, we get 20 liters of a 72% solution, because that's what we want at the end. Now what we need to figure out is what's going to go in this box right here. Now, let's try to answer this question. I have a car, and this car has a gas tank that holds 15 gallons of gas. I go to the gas station, and I'm going to fill up my car. My car holds 15 gallons. I go to the gas station, and I put in 13 gallons. How many gallons did the car have when it came to the gas station? Well, if your car holds 15, and you go in and you fill it all the way up to the top with 13 gallons, that's a difference of what? 2. So when you went to the gas station, your car had 2 gallons of gas, right? So that's what we did, is we subtracted them, because we knew we had 15 gallons total. And 13 plus 2 makes it 15. Same concept here. We take our total and we take away x. Now, what's our total? In this case, our total is what we get for box 3, so that's going to be 20. So box number 2 is going to be 20 minus x. It's always going to be the total minus x, because that's like figuring out how many gallons of gas are left in the car. If I go to the gas station and my car holds 15 gallons of gas and I have to put in 11 gallons to fill it up, I only had 4 gallons in my tank to begin with, right? I subtracted them. So whenever we don't know either one of them, we call one of the variables or one of the containers x. The other one is going to be the total minus x. And see, these x's cancel out, and that leaves you with 20 equals 20. Now let's go ahead and try to come up with our equation for the pure. And your pure is always the amount times the percentage rate. So I'm not going to solve these out completely. What I'm going to do is I'm going to get you to the equation, because that's where students struggle, is where does the equation come from? Solving it is usually not the problem. It's getting to that point. So let's see what our equation would look like. The first part, unknown amount, x, 60%. So 60% as a decimal, that's 0.6. And how much is in there? X. Those two go together to get you to that point. The next one, what's our next one going to be? Our next one is going to be 0.75, 75%. And what are we going to have to multiply it by? 20 minus x. And what is that going to equal on the right-hand side? Box 3, and that's going to be 20 times 0.72. There's your equation, and you can finish it if you want. You don't have to, but just so you see how I'm setting these up, so you could finish that. There's your equation, though. And that's where students struggle, is how do I put it together? Question 26 is very, very similar. And we're going to Use the same concepts and principles that we used in 25 to do 26. How many gallons of a fruit drink that is 50% fruit juice must be mixed with a fruit drink that is 20% juice to get 12 gallons of a drink that is 40% juice? So we want to combine these together to get a new fruit juice drink. I always like to draw my boxes here. I think this is the easiest way to work through these. I used to use a table to teach these, but I found that students got confused with the table. I used the table for a lot of years, but students just got mixed up with that. And I think the picture is actually easier. Okay, so what's the question say? How many gallons of a fruit drink that is 50% real juice? So that's going to be where we start at. You can label these with start if you want to. Doesn't matter. So we're going to start with an unknown amount of juice, X, and that juice is 50% pure juice. So half water, half juice. And we're going to mix that with a fruit drink that is 20% real juice. And just like the last one, we don't know what's going to go here yet because it doesn't tell us. But we're going to mix these together, and we want to get 12 gallons of a fruit drink that is 40%. And this is what we want at the end. So I need to make sure that I have 12 gallons of a 40% juice. So maybe you're working in a factory and you've got to mix these together so that you can label it and make sure that you actually have that 40%. And so I've got a 50% juice drink blend, unknown amount, 20% fruit juice blend, unknown amount. We need to figure out what's going to go here. Now what's going to go here is just like the previous one, and that's going to be the total minus X. So what do I want to end up with? Well, I want to end up with that 12 gallons. So this one is going to be 12 minus X there, because it's your total minus X. So that's what we're working with there. Now we can build our equation. And we build our equation by looking at the pure. And your pure is the amount times the rate. And so what do we have for our first one? 50%. So that's 0.5. How much is in there? Unknown amount, X. These go together to give you that. They always do the same. Let's go together to give you this. Then we're going to mix that with our second container. And it's 20%, so that's 0.2. And how much is in there? We found it to be 12 minus X. And what is it going to equal for box 3? Well, for box 3, it's going to be 12 times 40%. And that's 12 times that 0.4. can finish it from there. What we're trying to do is to make sure that we can set these up. Solving it is not the problem. It's all about setting them up. Now we're going to move on and we're going to do some investment problems. And I'll work out one or two of these investment problems completely. And then I'll do several where I just set them up. So we'll do one or two of these, and then we'll take a short break. We're going to begin with question 28. And these are going to be done in a very, very similar manner to the mixture problems. So what we're going to be looking at is we're going to be looking at investments. Now, if I invest money or have money in a savings account, at the end of the year, what happens? At the end of the year, I get a statement from the bank. And what's on that statement? How much money's in that account, the percentage of interest that it pays out, 2% or 3%, whatever it might be, and then how much it made in interest. So you've got the amount of money that you made in interest, your income, you've got the percentage rate that it pays out, and you've got how much overall money is in there, total. So those are the three things. Amount, we've got interest percentage, and we've got the interest that it pays out, money-wise. So we're going to look at 28. So Margaret won a prize for her work. She invested part of the money in a certificate of deposit, a CD, at 2%, and $3,000 more than that amount in a bond paying 3%. Her annual income was $390. How much did Margaret invest at each rate? This is going to be set up in a very, very, very similar manner to the mixture problems. Not much difference at all. Instead of using little containers, though, I'm going to use dollar signs. And this is question 28. We'll take a break after this question. We've got to label these. These are going to go together here, just like we did before. And we have two things that we're working with. So on 28, we're working with the CD, and we're also working with some bonds. So we've got the CD, and we've got the bonds. Each of these, again, are going to have an amount and a percentage rate. And then over here, this is going to give us our total amount. So now we got to fill them in. And what do we have? Well, it says Margaret's going to invest some of the money that she's got in a CD. And that CD pays 2%. So the 2% goes here. And we don't know how much she put in there, so we're going to use an X. Unknown amount at 2%. Then we come to the bonds. The bonds pay a little bit higher, so the bonds pay 3%. And how much is going to go in that bond account? Well, it says $3,000 more than that amount. Okay, so $3,000 more than that amount. That would be $3,000 plus X. Right? Because $3,000 more than that amount. Now, that $390 is interest. Interest does not go here. We want to add these across. So add these together because 1 plus 2 is 3. If I add these together, adding across, I get 2x plus 3,000. And you don't really have to do that. I like to do that. because students a lot of times get the interest and the amount of money mixed up. So like if I have a bank account, I get the savings account statement in the mail. Okay. Now there's two amounts on there. There's, let's say, $10,000 I've got in the savings account. Okay. Now that $10,000, it may have only made $30 in interest. So you've got an amount of interest that's the $30 and the total, which is the $10,000. So we need to make sure we don't get them mixed up. Interest is very small number. Total amount is a larger number. Just like we did with the mixture problems, we use pure. For investment problems, we use the interest. And the interest is calculated in a very, very similar manner to the pure. Interest is the amount that's in that account times, again, the percentage rate. Just like we did earlier with the mixture problems. Amount times rate. Now we're going to build our equation. And I'll completely work this one through, because this is a new one, so I'll work it all the way through. So on our first one, what do we have? 2%. So that is 0.02. How much is in there again? Unknown amount, X. That's your first fund. That's your CD. Now we're going to look at our bonds. And what's our percentage rate on the bond? 3%. So that's 0.03. There's your 3%. And how much is in there? 3,000 plus X. And we're working with interest, so this is going to be the total interest, not the amount. And how much total interest did I make? It comes from the question. It says, Margaret made now $390. So that's your total interest. So she made $390. Now we've got our equation. Now we can go through and find out our answers. So distribute that 0.03 through. That should be, 90, I believe. So let's double check and see what we've got. We've got 3,000 times 0.03. That gives you the 90 here. Plus 0.03x. And don't forget about the 0.02x in front. Combine before I move things around. So combine those together. And that's watch your decimals here, 0.05x plus 90. Now equals that 390. Be very, very careful with your decimals. Now we can move that 90 over with subtraction. And that's 0.05x. 390 minus 90, that makes it 300. We'll divide by our 0.05. And now we've got it. And we've got x to be now 6,000. Now we want to find the amount in each account. So we need to figure out how much goes with each one. So let's go back up and look at our bonds. All right, how much was in the bonds and the CDs? Well, we'll do the CD first. Sorry about that. CD is listed first, so we'll do it first. We've got our CD, certificate of deposit. How much is in there? X. So we've got our CD, and that's 2%. So for the CD, we've got $6,000 at 2%. That's your CD account. What about the bonds? Well, what do we know about the bonds? It's a little bit different. Okay, the bonds are this part right here. And the bonds pay 3%. So let's go back and look at our bonds. Okay, our amount in the bonds is going to be $3,000 plus X, so that's $6,000 plus our $3,000. So that gives you a total now of $9,000. And that's $9,000 at that 3%. So those are the bonds. You've got $9,000 in bonds, and they pay out 3%. Why don't we now take a short break? We'll come back and we'll set up a lot of these. We'll take quite a bit of time to go through and set up all these different types. So let's take about a 10-minute break, and let's meet back at 10:35. So meet back here at about 10:35.